Hello there, it's Team the Sudoers. This is our assignment for presentation. In this presentation, we will talk about first, architecture design, changes and impact. Second, the new component and alternative. Third, quality attributes and test plan. Fourth, our prototype point 2. And finally, conclusion and lesson learned.
Our system remains using a MVC pattern with integration of service-oriented architecture concepts. We now introduce a new component to enhance our system with self-adaptive software system features. The implementation of SAS is so that the application can observe the environment and its own state, and change its behavior based on its analysis of the observation. One known problem of our chatbot is that the web scraper may fail due to restrictions of shopping websites. In this case, no item is returned to the user and no item is added to the database. Self-adaptive software is a way to solve this problem. We introduced monitoring and analysis to detect failures by adding a logging feature to record events and messages when actions occur. We also introduced planning and execution to mitigate the situation when the bot fails to request for scraped data due to the shopping's website blocking the request, which usually occurs when requests to that site are made too frequently. To mitigate this issue, we store the failure and try again later to get around this issue.
Our main log tracks activity of all components like scraper, chatbot interface, and front end. A user can be system, anonymous user, and a registered user. The status tells if the component runs successfully. A reported failure can later be analyzed. The message gives the information regarding to the log. For example, message for web scraper includes keyword, number of results, etc. The component defines the component where the log message is from. Additional info is used for any additional information that may need to be passed to the log, such as the error codes. Here is an example of separate log that holds all the keywords that were not scraped due to the web scraper failure, as it fails to retrieve the item information based on the user's research. The ID is a random-generated unique identifier. The keyword is what's not scraped into the database, and the timestamp shows when the scraper was executed. The keywords will be used to run scraper repeatedly at scheduled time until it succeeds. Login starts running when the users open the website, when they log in, when they send the messages, and whenever the scraper runs. The login system always logs in timestamp and internal ID. If the login is triggered by scraper, then the searching keyword and scraping status will be logged in. The login component interacts with this web interface, so it logs when a user opens the website. With Amazon Logs, it logs when a user sends messages to chatbot, and with the scraper, it logs when scraper runs. The scraper script is also updated so that when it fails, it adds a keyword to the list of scraping failure, which updating the database too.
The new enhancement can have potential risks to the existing system. One would be the concurrency. Scraper can be called by a search item use case and the scheduled scraping of the failed keywords at the same time. We need a way to handle this situation. Another concern is that the machine to run the scheduled rerun can fail, although that is not very likely to happen.
One case that we analyzed that had failures within our program was web scraping. Given that web scraping is not always accepted, if you make more than allowed requests to shopping platforms such as Amazon, you'll get blocked from scraping for a short while. Due to this restriction, for our self-healing loop design, we will use a cron job that will run hourly to try and scrape keywords that were missed in a previous iteration due to any error. The cron job will be responsible to run the web scrape script and thus will update the database with the items if no error persists. An alternative that we discussed to the cron job route was running a Lambda function in AWS. The Lambda function would act as a scheduled job that scrapes data at intervals as well. This would not be machine dependent and thus will always run the job, whereas a cron job might not go through if the machine fails. After analysis, we decided to stick with the cron job because AWS Lambda is not free and would add extra costs. Going the cron job route requires us to monitor the machine running the cron job very closely, but we believe that this is an attainable task.
The new enhancement comes with new quality attributes. The biggest concern when adding new stuff to the existing system is that it does not affect the performance of the old system. The bottleneck for the new system should be the scraper, and that is the focus of design tactics here. We will plan to do the scrapping to happen when the traffic is not heavy. And then there are some quality attributes to test if the enhancement is properly working. The chatbot should be able to identify if a failed scrap is resulted by an invalid keyword, and any logging it outputs should be humanly readable. Formal one can be tested by sending a request to a search engine and see if there's a reasonable amount of response, and the latter one can be done easily by using UTF-8 encoding. Finally, we want the log to be identified by flags, and that is done by adding attribute fields when logging to a database. With the quality attributes in mind, we can now develop a test plan. To test the performance of the existing system, we can compare the response time before and after the enhancement is implemented. To test the chatbot's ability to find out if a keyword is valid and its ability to log non-ASCII characters, we can use fault injection, that is to manually inject incorrect inputs and see if the code can handle it correctly. Finally, we apply a database system test to verify if the flags are set as desired.
As the changes for this implementation were more so on the back end, to help us understand and debug issues down the road, the user experience is not changed and the user has the same functionality as it did in the 0.1 implementation. A link to the chatbot is as shown. An activity diagram as shown in implementation 0.1 is shown here. The changes are denoted by the green colored boxes. The first one is log data, which is done when a user enters the site, when a user logs in, when there is user interaction with the chatbot, and lastly when the system runs the web scraper. At the end of the scraper runtime, the scraper also now is responsible for adding failed keywords to the failed keyword log, which consists of all the keywords which failed to be scraped due to errors such as being temporarily blocked by the shopping platform. Additionally, this diagram shows on a high level how the cron job interacts with the system. As you can see again in green is the cron job that was added in this implementation, which invokes the scraper at hourly time intervals by reading the failed keyword log from the database. Here is a demo of the chatbot in action. So there are no changes for the end user as mentioned earlier. The changes that happened on the backend, which consists of the different APIs that are introduced to track and log the actions to then understand where the issues occur and then the characteristics of the said issues. So with that said, here are the APIs that we have. So for example, the first API is the overall, so the API call is the overall log that we are storing. So this is storing all the user actions, all the system actions, and basically the messages along with them and where they happened. Next up is we have a different API call, which is to the which stores basically the keywords that were not completely scraped or that were not scraped due to there being an issue with the web scraper. So as you can see, there's stuff ranging from actual words like desktop to gibberish. So the reason why the desktop might be there is because of Amazon's temporary restrictions on our web scraping, and stuff like this, which is gibberish, is here because when you search for gibberish and there's no search results found, it's also gonna be put here. Another API call we have is for the overall log, but now we're filtering by status, and we can check to see all issues that have status or all the log messages that failed. So have the status fail. Additionally, we can also filter by the component. So if you want to just look at the web scraper component, for example, and see all the messages pertaining to that. The next API call we have is It's an extension of the last one where we're looking at the component. So for example, here, this component we're looking at is web scraper. And on top of that, we're also looking for the status. So we're filtering by the component and status. So in this case, we're only getting the failures for the web scraper component, which, yes, so that's what you see. And lastly, last filter that we have is on error codes. So we have specific error codes for specific actions that the bot recognizes or that our system recognizes as errors. And one of them is bot invalid command, which occurs when the bot doesn't know when to or what to respond with, and because it doesn't understand what the user wants. And another one is web scrape action, web scrape fail, which occurs when the web scraper fails. And yeah, so now let's actually try on our bot itself. So if I do a quick refresh of this page and I go all the way down, you can see the first call that we store in our overall log is the user has visited the chatbot website, and that's because that's what happens when you first come to the website. Next, I'm just going to type in, first I'm going to try type in just the word dummy, just because that's something that the chatbot doesn't recognize. And as you can see, it says, sorry, what can I help you with, right? At the same time, if you go down into our logs, we see that we get a new log message where the user input was dummy, and we can see the error type is bot invalid command. So it logs those, and we can analyze basically what the users are wanting to search for, as well as all the extra stuff that the user is putting in that we don't support. Outside of that, the functionality in terms of the actual searching stays the same. So if I type I would like to find, and then ask me what would you like to find, we give it desktop, and we're going to get a list of all the desktops that we have in our database. And because we have some stuff in our database with this keyword, we're getting data. And if we go back to our log, we can go down and we can see that our messages are stored once again. And lastly, the last thing I want to show is when we are trying to put in something that doesn't exist. So we have made a keyword on our web scraper that causes a fault and kills the web scraper because we can't really reproduce when Amazon blocks us. So this is what we're going to use to show how the logs are, how the messages are logged when there is an error with the web scraper. So if I do the same thing again, I would like to find, and I'll put this keyword right here to add a fault in, and it's going to say no results found. That's because there's nothing found. But at the same time, if you go back into our overall log, we're going to see that it tried to web scrape, and as you can see in additional info, it says web scrape fail, and this was when the keyword is equal to fail script fault. And yeah, so that tells us that that failed on this keyword, and basically the reason for this would be that Amazon restricted our access. And if we go to the search log here, we're going to see that we have the failed keyword now added to this list as well. This will then be ran with the cron job design, as we mentioned earlier, to scrape all the failed keywords and add them to our database.
In conclusion, we planned to implementation of an enhancement based on the idea of self-adaptive software, while keeping the previous MVC architecture model and SOA concepts. The addition of logging not only helps solving the problem of failed scraping, but also has the potential of being important to solving other issues in the future as an essential part of the SAS concept. Lesson we have learned in this assignment. Adding new components to the existing system is useful for achieving goals, but one must be careful when designing how the new components should be connected to the existing components. The larger the system is, the more complicated it could be. Also, when adding new components, we need to think about the possible addition of other new components in the future. Finally, when considering alternative options other than cron job, we decided to take the risk of machine failure. This reminded us of the probability of database failure. Maybe in future implementations, we will make database backup or use two databases to make a RAD1-like structure. Thank you for watching. Please leave any question below. We would like to answer them.